This session covers introduction to Calculate.io, how Calculate Data Hub is being used to collect data from various field assets and integrate the data with AWS backend services. This is a high-level block diagram of how Calculate.io is being used to integrate with the field assets with AWS backend services. So, as you can see in this deck, the Calculate Data Hub has got different data hub services called DER Data Hub, Telemetry Headend, Metering Headend, or IoT Data Hub. And these data hub services are primarily used to collect data from various field devices on the native protocols. For example, the energy meters, which is available in the solar farms, their inverters, microgrid controllers, or it could be IEDs, could be field sensors, or could be RTUs or PLCs available in the field. It can also use to collect data from the OT application softwares like SCADA systems or HMI systems available in the on-premise servers, or it could be data historians available on on-premise servers. The data from all the field devices or any of the field devices can be collected on the native interface, and it can be shared with AWS services using any of these, or maybe a combination of all the three services which we have shown in this diagram. Using Kinesis Warehouse or AWS S3 primarily to push or inject data to the AWS SQS primarily to handle the high priority data like events or commands. So once data is available at the AWS on the customer's account, and data can be used for advanced applications like time series data storage or IoT analytics, or it could be used for visualization applications or other AI or ML engines. This is a typical solution architecture of using Calculate Data Hub for integrating the OT field devices from solar or wind farms with the AWS backend services. Here you can see that Calculate Data Hub, which is deployed on AWS, having the native protocol drivers or protocol adapters to connect with the field devices like RTUs or PLCs and collect data using telemetry protocols like Modbus or DNP3 or 104 or any other telemetry protocols. And this field data can be integrated with AWS services like Kinesis Warehouse, S3 or SQS using the native AWS connector available in the Data Hub. If the field data cannot be directly connected from the RTUs or field assets, it can be collected from the SCADA softwares, which will be available on premise in the solar or wind farms. Typically, solar or wind farm SCADA as well as post data on OPC protocols like OPC DA or UA format. So, Calculate Data Hub can be used to connect with the SCADA system and collect data from the SCADA on OPC protocols, and the collected data can be integrated with the Kinesis Warehouse or S3 or SQS services in the AWS. In some cases, even data cannot be available in the SCADA systems or from the RTU. It could be available as a database file, or it could be available as a custom file format. In those cases, we have a custom adapters built in Calculate.io to read the files directly from the field devices and pass the data and send it out to the AWS services. So all the data which is collected from the different types of assets, that is SCADA system, field devices or files, all the data will be available to AWS on a canonical standard format. So the application which is developing on AWS need not worry about the native protocols or uh, the interface format which Calcio is using to collect the data from the field assets. So this interface will be canonical, which means or a native interface, canonical interface implementation will meet all the different types of field assets integration with the AWS. So the solution also uses proxy services which will be installed in the on-premise systems. The proxy is primarily uses a secured as PK certificate issued by the Calcio Data Hub and use the certificate to create a secure TLS 1.3 tunnel from the field location with AWS Cloud. And all the data which is communicating from the field assets, whether it's scatter data or RTU data or any file data, will be through the Calcio proxy, which makes that there's end-to-end communication security in the architecture. Coming to the demo, what we'll cover is simulation of an RTU device using a simulator device simulator tool called ASC 2000. This tool basically simulates a DNP3 device or DNP3 RTU, and we also uses a OPC UA simulator to represent the SCADA systems. So the data from these two simulators will be collected by the Calcio Data Hub, which is again deployed in the AWS, and the native interfaces of these field assets will be used, like in this case OPC UA or the DNP3 will be used by Calcio to collect data from the simulated devices. The data hence collected from these devices will be integrated with the AWS services. So the commands data which is given to the DNP3 simulator will be issued from AWS SQS, and input data from the field will be injected into AWS Kinesis warehouse or to the S3.
Now we'll be demonstrating the data flow from DNP3 to Calcio Data Hub via Calcio proxy. We'll be briefly visualizing the DNP3 data in Calcio as well as go through the configuration of AWS connector, which pushes the data further to the AWS environment. Typically, we'll be verifying the device data in the Amazon S3 storage. The reverse data flow from AWS will also be demonstrated, wherein a DNP3 command will be issued from the SQS service and the command execution will be viewed in the DNP3 simulator end. For DNP3 simulation, we are using the ASC 2000 tool. So here is ASC 2000 tool, which is currently configured to act as DNP3 slave. Typical data points corresponding to an RTU in solar plant is considered. As you can see, sample currents, voltage and other data points are configured for a cyclic simulation of 10 seconds. The DNP3 communication is up and running and the data is currently fetched by Calcio. As we move on to Calcio, we can visualize the device DNP3 data in the device data page. As you can see, the DNP3 data is already available in Calcio. As we refresh, we can see that the device data is continuously flowing into Calcio. We'll now briefly view the AWS connector configured in Calcio. As you can see, these are the AWS parameters configured, such as the AWS region, the Kinesis data stream, the queue names, as well as the S3 details, along with other details, and the AWS credentials configured for routing the information to the AWS S3 bucket. Now we'll be visualizing the DNP3 data in S3 location. So here is the S3 location wherein the DNP3 data is available in the DNP3 RTU device folder. As we sort with the last modified time, we can quickly view one of the files to see the latest data pushed to S3. As we can see here, the current values are already pushed to the S3 location. We are
Hello, welcome to this part of the demo where I'd be demonstrating Kalki.io as a data hub for collecting data over OPC UA. Kalki.io would be acting as an OPC UA client to collect the data from an OPC UA simulator via Kalki.io proxy, which is making a TLS 1.3 connection, a secure channel between the field devices and the data hub. The Kalki.io proxy would make the TLS 1.3 connections through which the data from the OPC UA is being collected by the data hub. Once it is collected over to the data hub, it would be then pushed towards the Amazon S3 or Amazon's infrastructure through an AWS connector. Essentially what in the part of this demo we would be seeing is how it is getting connected or how the data is sent towards the Amazon S3. Now let me quickly show you the data model that has been used. So for that, what I'm using is an OPC UA client, which is UA Expert, through which I've connected to the OPC UA simulator, which is an OPC UA server. As you can see, there is a solar station ABC, which is been modeled as one inverter room under that one, and which is having a couple of inverters under that. Each inverter is having some 8 parameters under it, which is as you can see, DC current, voltage, frequency, total generations, PF, the performance ratio, of which are the part of the interest of the demo. What I would be showing is how we can actually collect the data for a historical period from this particular tag, which is PR. Now let us try to browse the same thing in Kalki.io. So this is how the Kalki.io's landing page or the login page would look like. Each account in Kalki.io would be having an user ID and password to log in, so that it would be securely logged in to that account. Let me log in to this account here. As you can see, there are devices and we have got device templates, which has got different types of templates which the data hub can actually cater to. Can it be a energy meter? It can be a DNP3 device. The DNP3 device we'll also be demonstrating, and we have got something called a SCADA, which is my interest of the demo here. Let me drill down to the SCADA part, where I have configured it as a sample SCADA, where in which one more drill down of that would give you the instance of the SCADA that it is being that we are talking out here. I've just named it for the sake of it, that is a generation station East 1, which is getting connected through a network proxy, and it's a make and model is of so and so. So going into the UA part of it, or how do you browse the data model, something like this, where you drill it down, you can actually see the root node of it, and if you still further drill it down, you can actually see these are all these parts of standards of the standard parts of, or the parts of the standard OPC UA standard. And here it comes the solar station ABC, where under that solar station ABC you can see that inverter room, which is similar to this what we have seen in that OPC UA client, the model that I've shown you a couple of minutes before. You have got our inverter 1A, and under the 1A you have got 1A PR, where this is the our point of interest. and this is what the tags would look like. Now, there are different ways in which we can actually acquire the data from the Calcio Data Hub. One method would be to read the historical data. That is an on-demand poll that I'll be doing it right now. We can also do something called as a scheduled data read. A scheduled history read is also possible, where in which you can actually specify that at the intervals at which the schedule read to happen, and during at that times this would go and then read it. We also have the support for subscription-based data acquisition, where in which we'll be adding these data into those subscription endpoints, and those would again, based on the subscription parameters configured, would collect the data and send it out towards the next connector, which is onto the S3 IoT, S3 AWS S3. Now let me do this read history data here, where I'd be asking for the data from Jan 1st, let's say 12 a.m. to today, and let me initiate this poll. So once this is initiated, what Calcio Data Hub would essentially do is to fetch the data of the tag 1a_pr from the OPC UA simulator and send it out towards the S3 bucket. Now the S3 bucket that I've been interested to see is this one. Okay, this is S3 KLK and the under Calcio demo. This is where the data would come, and this is where we could actually see the data. Let me just give it a quick refresh so that I'll get the latest one, which it has come, which is this one. So yeah, this is a file that it has sent it out to the S3 on a JSON format. Let me quickly open this. Simultaneously I'll open, so yes, so this is where the data has been come for this particular tag. As you can see from the OPC tag name, it is Solar Station ABC Inverter Room 1, you enter A, 1_pr is what the tag name is. We have got some, 13 points under this. Let me show you the same thing in the client as well. Let me bring that up. So the same thing for 1pr. Let us see the historical trend. Yes, so for this from 1st to 22nd, let's give it an update. You can actually see the numeric data. Yes, so this is what the data is. The last data is of 58, the first data is 10.1 is the value. And the same thing, you can see it here as well. The last data is 58 based on the timestamp. It has been, it has been printed out here, and the first value would be 10.1. So that's essentially the demo for how we get the data from OPC UA till the Amazon S3. Thank you. Let me know if at all you have got any questions.